Good evening, kiddos. This is the transformation review walkthrough. So I'm not going to do all of them, but I'm going to do a lot of them and go through and kind of touch base on the major things that we're doing. So keep in mind that transformations are a way of moving a figure around. We have rigid and non-rigid transformations. The rigid transformations we went over were translations or slides. We also had rotations and reflections. The only non-rigid one we did were dilations. For those of you who don't know, this is Cleo. She'll be yelling at me for most of the video. That's what she does. Anyway, so let's look at number 1. And we see the translation of the slide is x minus 1, y minus 3. So that means we're going to take, so what we do is we first identify all of the points we have. So t is 0, 0, the origin, u is 1, 4, and v is 4, 1. So the rule says that we go x minus 1, y minus 3. So literally that's what we do. We take each of the x values and subtract 1. Each of the y values and subtract 3. So 0, 0 becomes negative 1, negative 3. 1, 4, we go 1 minus 1, 0. 4 minus 3, 1. For v, to get to v prime, we go 4 minus 1, 3. 1 minus 3, negative 2. Then graph those points, t prime, u prime, v prime. Connect them dots, and there we go. The next one we deal with is a dilation. Now, a dilation is a non-rigid one, and there are two types of dilations, an enlargement and a reduction. If your scale factor, or k, is larger than 1, then you're going to be looking at an enlargement. If it's less than 1, it's a reduction. So a dilation of 1.5 is going to be bigger. It's going to get half as big again. Now, this is pretty straightforward. We take our point, so let's say I is negative 2, 2, and we're going to multiply each one of those by the scale factor, in this case, 1.5. Well, 1.5 times negative 2 is 3. So negative 2, 2 becomes negative 3, 3. Right there. Whoa. Too much too soon. H, 2, 1. Multiply both of those by, I need that, 1.5. And we get 3, keep hitting the wrong button, 3, 1.5. Now, if you're being asked to come up with a half like that, just eyeball it. That's H prime right there. J, we have negative 2, negative 2. That's going to go to negative 3, negative 3. And we go like that. So the next thing we're going to do is rotations. Now remember, we have 3 rotations, counterclockwise, 90, 180, and 270, and they each have their different rules. For 90, we know that xy, that's any given point with an x coordinate and a y coordinate. When we rotate it 90 degrees, it becomes negative yx. So what that means is we take the y coordinate from the first point, put it in the x place, and then change its change its symbol. It's positive, negative value. So r here is 2, 4. S is 3, 3. Q is 2, 1. And T is 3, 1. So for each of these, so for Q prime, we take that 1, which was the y, and we put it in the x spot, change its value. Negative 1, 2. R would then be negative 4, 2. S, negative 3, 3. And T, negative 1, 3. plot those. And you can see that that is in fact a 90-degree rotation counterclockwise. Next up, we have a reflection across the y-axis. So a reflection across the y-axis, all it does is it changes the value of, or the symbol of the x. So if this was the x-axis, it would be the other way around. It would be xy goes to x negative y. But it's not. It's the y-axis, so we just switch the value of the x. So here, we know that q is -2, -4. So we change the value of the y to +2, -4. R goes from -2, -1 to +2, -1. S, -5, -2. +5, -2. Whoa. And that's what it looks like. See how it just kind of flipped wrong. Flipped over right there. Do the same thing with number 6, except it's going to be heading back that way. So the rest of that other page are very similar things. So you now have, with what we went over, you have the ability to solve all of those problems. So number 1 is just like the ones we already did. Number 2 is a little different-ish. So it's in vector form, so it's -1, -7. What that really means is x minus 1, y minus 7. It's just a short way of writing it. So we do the exact same thing. Z, we go back 1, down 7. Y, back 1, down 7. W, and X, back 1, down 7. Then we get that right there. Easy peasy. Next, I'm going to look at number 5. So when you have a line like x equals 5, it's this line right here. Count over 5. 1, 2, 3. 5. Up and down. So when we flip it, it's really straightforward. We basically count how many spaces from F to the line, 2. So we count 2 after that. G is 3. It's 3 to the right, so we go 3 to the left. And that's it. For y equals -2, it would be this line right here. And so now, instead of flipping it left to right, you'd flip it up to down. Now, y equals x and y equals -x have their own rules. Y equals x, that line right there, xy becomes yx. So we switch them. If we have y equals -x, like we do in number 8, xy goes to -y, -x. So we switch them and we change the sign. So let's walk through these. P is 1, -1. So we switch those and we get -1, 1. That's P prime. Q, 7, 1 goes to 1, 7. Q prime. S, -1, -7 goes to -7, -1. And R goes from 5, -5 to -5, 5. That's what it looks like. Again, if you could fold this, if you could fold this on the reflection line, they'd lay exactly on top of each other. For y equals -x is a little bit different. Notice that here, the line actually goes through the figure. There's nothing wrong with that. Everything on the left-hand side of the line is going to get reflected over to the right. Everything on the right-hand side is going to get reflected over to the left. So because this is y equals negative x. I want to look back over here and see that xy goes to negative y and negative x. So we're going to switch the positions, 0 and 5 are going to switch. But instead of just switching it like we did for y equals x, we're going to change the sign on both of them. So e, which was 5, negative 1, is now going to be 1, negative 5. See how we switch the positions and the sign? So notice that D and E, both on the right-hand side of the line, got flipped over to the left. Now because F was on the left-hand side of the line, she's going to get flipped over to the right. 3, negative 6 goes to 6, negative 3. And there we go. So now the last couple that we're going to do, no, wrong button. So number 11, 270 degrees counterclockwise. So counterclockwise, xy goes to y negative x. So notice here, though, that we're not doing it about the origin. Instead, we're doing it about the point 24. This is where we set up our little phantom graph. So now what we do is we treat that phantom point, that 24 point, as 0, 0. And we say, if that was 0, 0, what would n and m be? Okay. So we go, okay, well, n would be 6, negative 1. So rotating that 270 degrees, we switch our x and our y, and we change the value of what is x. So we're going to take that 6, make it a negative 6, and then switch them around. So we get negative 1, negative 6. Now when we plot this, we're not going to plot this off of 0, 0 right here. We're going to use our phantom graph. Right there. And then take m, which is 2, negative 5. Switch it around, and we get negative 5, negative 2. Again, we're using it off this point right here, our center of rotation. And there you go. See? Pretty, pretty. Next, so we know how to do dilations like 13 and 14. They're centered at the origin. Number 13 would be an enlargement. It's going to get 5 times or 4 times bigger. 14 is a reduction, meaning it is going to get 3/5 smaller. To do that on the calculator, multiply it by 3, divide by 5. So what I want to do is I want to look at number 15. Number 15 is K2, centered at negative 3, 4. So again, we're going to set up our little phantom graph there, and then kind of recalibrate it, so to speak, around that point. So B, in relation to our center of dilation, is 0, 3. C is 1, 5. And D is 7, 2. So we now multiply all of those by our scale factor, 2. 0, 3 becomes 0, 6. 1, 5 becomes 2, 10. And 7, 2 becomes 14, 4. Remember, when we're graphing these, we want to graph them from our center of dilation, not from true 0, 0. And that would be that. Hey, Cleo. It's number 16. I'm going to do this for you, too. So it's centered at 7, negative 2. So some of these you might be asked to then find the actual point. So these you need to actually do from 0 to 0. So once you find the phantom points and graph a figure, you may be asked to actually state the coordinates of, your prime enlargement or reduction. And for that, you do need to reference 0, 0. So for 16, our point is 7, negative 2. We're going to recalibrate it. So 3, 6, negative 6, negative 6, 0, negative 9, and negative 6, 0. Keep in mind, these aren't their actual coordinates. These are just their coordinates in relationship to the center of dilation. So we then multiply each one of these by 1/3, which is the same thing as dividing by 3. 3, 6 becomes 1, 2. And that's because 3 times 1/3 is the same thing as 3 divided by 3, or 1. 6 divided by 3 is 2. 9 divided by 3 is 3. So W prime becomes negative 2, 0 again. These are in relationship to the center of dilation, not the actual origin. So 6, negative 6 becomes 2, negative 2 for Y prime, and 0, negative 9 becomes 0, negative 3. And we graph it, and it does in fact look like a third scale of the pre-image. So that's it. Hope this was helpful. If you have any questions, feel free to talk to me before the test. I hope everyone has a wonderful evening.